Welcome to the next video. Choosing the right and cost-effective solar energy system has become increasingly important. In this video, we will compare the solutions and investment costs of the SolarEdge Rapid Shutdown system and the traditional inverter solution using external PLC. First, let's understand the working principles of both solutions. The SolarEdge Rapid Shutdown solution combines the SolarEdge inverter with the optimizer signal shut-off device. In case of a fault, the inverter sends a shut-off signal to all the optimizer shut-off devices. This ensures that the current rapidly reduces to a safe voltage threshold. This solution is directly integrated into the SolarEdge system and complies with international safety standards. With the solution using external PLC signals, a PLC system is used to transmit the shut-off signal from a central point to all the devices in the system. This signal will reach the DC shut-off devices, which will then cut off the DC current for safety. However, this solution requires using an external PLC system, which poses risks of delay, multiple signals, and dependence on AC power. Now, let's consider some important factors when comparing these two solutions. 1. Reliability. The SolarEdge Rapid Shutdown solution is directly integrated into the SolarEdge system, increasing reliability and reducing dependence on external components like AC power. 2. Delay. With the SolarEdge Rapid Shutdown solution, the shut-off signal is transmitted directly from the inverter to the optimizer shut-off devices, minimizing delays and ensuring a quick shut-off when needed. 3. Simplicity and convenience. The SolarEdge Rapid Shutdown solution is simple in design and directly integrated into the system. This makes installation and operation more convenient compared to using an external PLC system. 4. Power and project scale. PLC-based systems are typically suitable for small projects with low power capacity, while SolarEdge systems are suitable for both small and large projects with high power capacity. Now, let's examine the cost differences between the SolarEdge system and the inverter system using external PLC. 1. Equipment cost. The SolarEdge system comes with integrated power optimizing optimizers and accompanying accessories. It does not require additional wiring design or cutting space between inverters, so inverters and power cabinets can be centrally placed for easy connection, operation, and maintenance. On the other hand, the inverter system using external PLC requires separate PLC systems for each inverter. Installation must comply with strict wire and cable spacing requirements to ensure noise resistance, leading to more installation costs, labor, cable trays, and ongoing operation costs. 2. Labor and installation. The SolarEdge system has a simple and integrated design, minimizing installation work and time. The inverter system using external PLC requires more complex independent DC cable and cable tray installation, which can increase installation costs and project completion time.
3. Operation and maintenance. The comprehensive integration of the SolarEdge system facilitates maintenance and support, ensuring stability during operation with synchronized hardware and software. The optimizer signal devices can be managed and monitored from the SolarEdge Control Center, reducing operation and maintenance costs with per-panel monitoring technology. Superior performance with the optimizer technology reduces the impact of shading, dirt, or power loss. In contrast, the inverter system using an external PLC has asynchronous hardware and software, making the system unstable and generating operation and maintenance costs. Operating personnel may require specialized knowledge and skills for maintenance and support. Next, we will share with everyone a list of materials estimated for a sample project installed on the roof of a typical factory. The design estimate covers a roof area of 7,000 meters using YAR 550-watt solar panels, with 1944 panels, equivalent to a DC capacity of 1700 kWp. This is the design of the SolarEdge solution, where the yellow line represents the path of the DC cable array running on the roof. 9 inverters will be concentrated at positions on the ground at the roof corner. The AC output cables of the inverters are connected to a 1600 amp electrical panel and then connected to the power grid. The following are the simulations of the design using the external PLC system combined with traditional inverters. The number of cable trays carrying DC wires on the roof is evenly distributed. The cable paths for the inverters are separated. Inverters are evenly distributed around the roof to comply with the PLC external solution standards. According to this design, we can see that the PLC solution will require more cable trays, AC and DC wires, and related materials, resulting in increased system costs and construction time. This is an Excel spreadsheet detailing the material calculations for the two solutions. Both of these solutions use 9 inverters. For SolarEdge, 972S120 optimizers are used, while the PLC solution employs 972 sets of RSDD and 9 sets of transmitter PLC. The SolarEdge signal cables are directly connected to the inverters, whereas the other solution requires an additional data blogger to store and transmit data. The SolarEdge solution currently has higher costs in terms of main materials. Now, let's examine the AC and DC cable costs for both solutions. Due to the individual placement of inverters in the PLC solution and their increasing distance from the AC distribution panel, the length of the AC cables will be significantly longer, almost 5 times longer than the SolarEdge solution. The number of solar panels per string in the SolarEdge solution is nearly double that of the traditional inverter string solution, resulting in less DC cable length for the SolarEdge solution. This category incurs higher costs for the PLC solution, almost double that of the SolarEdge solution. For mounting rails and pins not installed, both systems are similar when installed with the same number of solar panels. AC and DC cable tray systems. As analyzed earlier, the strict wiring requirements of the PLC system will require more AC and DC cable trays compared to the SolarEdge solution, resulting in additional labor and construction time. The cost of the cable tray for the PLC solution is twice as high as that of the SolarEdge solution. The remaining categories have similar costs for both solutions, with only a difference in the distribution of inverters between the two solutions, resulting in higher installation costs for the individual inverters in the PLC solution compared to the centralized placement of SolarEdge. At this point, the overall construction costs of the two solutions are nearly equal. The PLC solution may incur additional costs due to the difficulty in meeting technical standards, prolonging construction time. Installation and operation are also important considerations when using the PLC solution. With a comprehensive approach to solar system safety, SolarEdge's PV solutions exceed the existing safety requirements in the industry, monitoring and minimizing panel-level incidents, adhering to the strictest international safety standards, including FM's Global's DS1 to 15 technical requirements. We hope this video helps everyone understand the rapid shutdown solution in the market and calculate the costs when designing a solar energy system. Thank you for watching this video.